morning, everyone. Ladies and gentlemen, it's my pleasure to be here and have this opportunity to present to Musharaka conference. I also particularly grateful to my friends and colleagues and students in Oman who still remembers me and have invited me kindly to this conference. So I'm grateful for that. I'm also welcoming the people in the cloud who I can't see, but possibly you can see me. I hope you enjoy the talk. So today, this morning, I'm going to talk on smart grid overview, some lessons learned around the world. Particularly, I draw on some examples from Australia. And in 2015, I had the privilege of working with some colleagues at Sultan Qaboos University in developing a precursor smart grid roadmap for the Sultanate of Oman. So I will draw and share some of those recommendations with you toward the end. I'm very conscious about the time. I designed this talk for about 30 minutes. I've been given 20. So I'll be flicking through some of the slides, so please forgive me for that. Okay, so this is what I'm going to talk to you about. I don't want and expect you to read this. I rather move on. So this is where we used to have our electricity system. We all know, okay, it was basically a one-way traffic, power generation, transmission, distribution, and to the loads. Things have changed. We are no longer there. We are entering into an era of a transformation of electricity network that goes from the conventional grid to hopefully what we believe is going to be smarter and smart grid. It's not that the electricity companies are not smart. When you approach and the utilities and you say that, okay, you are trying to advocate smart grid, they'll be saying, well, we are already doing things smart. Surely they're doing things smartly. Majority of these smart technologies have been in the transmission domain. Basically, the smart grid technology is embracing the distribution system. That's where most of the transformation in smart grid technologies are. Okay? So basically, it becomes then a maze of distributed energy resources, ICT, communication infrastructure, okay, microgrids, nanogrids, and that forms the smart grid. All right? So smart grid basically is going to make some changes, and that is from the consumers. The consumers are going to be prosumers. So no longer that people just consumes energy and pay the bill. They are also producers. So we call them now prosumers. Okay? Centralized energy supply is going to be into distributed generation. Basic infrastructure is going to be smart networks. Energy intense is going to be energy and carbon efficient. In Australia, we just released our 2017 Electricity Network Associations or ENA's plan. And that plan suggests that by 2050, Australia will be carbon free in power generation. So there will be no carbon emission from power generation in Australia as per their plan from 2050. So a very ambitious plan. Centralized operation to becoming distributed operations and operators. Expanded networks to follow load growth, utilizing existing network. Investment in electricity infrastructure is very expensive. And if we can manage the network without investment in new infrastructure, is going to save money for the consumers. Australian, same plan, 2017 plan, is suggesting that by 2027, every consumer in Australia, in real Australian dollar terms, will save $400 in electricity cost. And that will come from managing the load, the generation, utilizing infrastructure, the savings will come there. And that's what is the plan. Monopoly grid is going to change to nano grid and micro grid. No longer that the grid will have its, no longer the grid actually have its monopoly. Okay, so elements of smart grid, what makes grid smarter are these, some of the things like distributed generation, active distribution network, micro grid and clustered grid, self-healing resilient networks, intelligent communication, PMUs, that is phase of measurement units, IEDs, smart meters and demand management, home area network, HAN, LAN, WAN, etc. Interoperability is a big thing. Okay, flexible AC transmission, flexible AC transmission, and adoption of ICT and wide area monitoring and control. Some of the smart grid projects that has been going on in the world, like in USA, there have been 130 projects that was funded under the Obama administration, okay, during the Prof funding, and it was matched by private funding, and they had 130 projects. In Europe, there have been EU-funded projects, and some of the examples are given there. In Australia, we had the Smart Grid Australian projects. That was a private and public investment of $400 million in Energy Australia, basically to look at demand management and its impact. Okay, a similar initiatives are taken in Denmark, in Japan, in other parts of the world. India recently announced they will have 100 smart cities, of which the smart grid will be the biggest component. So this is what I'm talking about. Okay, so a house typical, which used to look like that, we get our electricity from the grid and we pay the bills. Now a house actually is going to look like this. So it is no longer just an electricity meter coming into our house, but we can have rooftop PV, maybe rooftop wind turbine. We'll have the battery energy storage. We'll have ICT infrastructure, and a lot more in a smart house. And this is how the house being transformed now in the Western world slowly. In Australia, there are many houses which is now almost resembling this, what I show you here. Okay, smart meters are being a big part of a smart grid, and they can be used for automated meter readings or automatic metering infrastructure, which is much bigger than automated meter reading. Now I'm going to show you an example that is right here in Sultanate of Oman. I had a student from the Muscat Electricity Development, and he showed me that his company, what they are doing is implementing smart metering in automated meter readings. But I told him and gave him the project. When he asked me, what can I do? I said, you have got lots of data. You're not utilizing it to the best potential. Why not you use this data and look at your load curve and come up with real-time pricing infrastructure that will maintain your peak demand, as you see by the dotted line in that picture. So we can use smart meters for many purposes in managing our assets, and this has got the biggest impact that it could reduce your peak generating unit need, which you only use 2, 3, 4, 5% of the time in the year. So this is a non-wise investment, and you could actually do away with that. Some of the things that in a smart grid you could do, like this is the project that I did in Western Power, our local utility, at the edge of a grid, and they had voltage problem there. We simply provided a container full of PVs with inverters, and that produce reactive power as a solar capacitor to shore up the voltage at the grid. Okay, these are now the storage techniques that is available, various kind of storage technique. I don't have the time to go over them, but on the left you see the ratings and what kind of storage you can use, and on the right is the pricing per kilowatt hour. So for example, lithium ion is now becoming very, very popular. It's about $500 a kilowatt hour. It's still not so cheap, but it is providing a good alternative energy storage solution. This is an example in Perth where I live, and this is a warehouse, okay? And they had this vision of basically reducing their electricity bill, but the company has got a policy, the Western Power, the local utility, that is, if you install rooftop PV in commercial infrastructure, you cannot export energy into the grid. And that is because so they can manage their grid, because 30 kilowatt or more, if there are 300 people doing that, then it's a 9 megawatt, and you have a problem of frequency. So they were worried about it, so it's a zero export, okay? But this company basically put in that battery energy storage, the solar energy system on the rooftop, and it saved 68% of his electricity bill. So you could actually do a lot of good to your company by doing that. Now this is an interesting exercise which shows you that what can you actually do in order to minimize your peak demand. So sorry, my battery, the laser pointer is, I'm unable to show, but basically what you see here on the left hand side, that red bar is the peak load that is used for 2 hours. But look, if you could then use, and on the left you also see the photovoltaics generation. On the right, what you see on the photovoltaic generation, charging the batteries. But then you can use to discharge those batteries to basically cut away that peak demand that you see on the left. And what that basically means is that you could use energy storage system as an alternative to your peaking units, and you could save a huge amount of money in terms of your peak generating unit investment. That's another example in, again, in my city is Synergy is a utility, and what they put in is basically is a residential subdivision, which by law everybody has to put rooftop PV on their house if you are going to build. And then they put in a centralized battery storage system, so they could store their daytime generation into the battery storage and use it at night. And that's because the feed-in tariff was taken away from the customers. So therefore now they are using their own solar during the day, at night, and becoming independent from the utility. So that kind of investment is going on. That's the Alkimos Beast energy storage system. Okay, that's the storage system that I mentioned. It is lithium-ion batteries, and it's basically kept in container, and it's air conditioned at 20 degrees Celsius, because lithium-ion, if the temperature goes to 40 degrees from 20 degrees, you halve the life of the lithium-ion. So therefore, you have to maintain it very well. Okay, virtual power plant is another opportunity that we could now use, essentially collecting all our distributed energy generation and other opportunities of demand management in this fashion. So basically, as you can see, that there's a lot of communication and ICT that is required in this scenario. But basically, you could form a spider mesh through ICT and digital communication, and then run what we call a virtual power plant. And you could become dispatchable virtual power plant as well if you manage it well. So power plant does not have to be centralized. Okay, this is an example from our local utility which I was involved in. Basically what it is that it's a Path Solar City project. So we took a distribution feeder, and that serves 77 houses. The utility paid people to put in rooftop PV, and it was a study to see what it will do to the after diversity demand, peak demand for the houses, as well as the voltages of the network. Because everybody was worried that if you have too much photovoltaics, then you will disturb the network in terms of its performance. Well, the answer is not really. So that's actually, we monitored all the houses with and without photovoltaics, and that's there you see on the bottom left you see the photovoltaic generation. On the top, what you are seeing is basically the ADMDs from the 2 kilowatt PV system and from the single phase 2 kilowatt PV system as well. So basically what you see is the after demand diversity. As you can see that a lot of the time, the demand of the house is actually below zero, and that's because the house is a net exporter now to the grid rather than consuming. So this is what you see here that happens to the voltage when you have got rooftop photovoltaic in your network. So still you could be within the plus minus 6% band. Okay, so there is not much of a worry if you are going to do photovoltaic investment in your network. Okay, that's the voltage profile on distribution transformer. That's also doing well, and without photovoltaics, we already have this situation. So situation did not change after introducing the photovoltaics. It actually improved. Interesting thing is this is the demand from that distribution transformer. Do you notice here that there is a period of time, and that is when peak PV generation is, the distribution transformer is sleeping. It actually has no transaction through it. Okay, that's an interesting feature. So that could actually increase the life of distribution transformer. Okay, electricity vehicle. Okay, now there are different opinions about this, but electric vehicles are going to come. A lot of initiatives now been taken. For example, UK and France is going to stop producing ICE engine-driven cars by 2040, 2050. So we surely are going to move toward a electric vehicle future slowly. There's a lot of electric vehicles now available in the world. These are all commercial, okay? And what you see, this is what is going to happen to us and electric vehicle and our houses. That's I don't have enough time to discuss this, but this is in Australia, the probabilistic arrival of vehicles into their home. And as you can, what we know now is that there will be lot of battery charges left once a car arrives at home. So what does that mean is that not only that grid to vehicle, but we'll have opportunity for vehicle to grid transfer as well. So the vehicles itself could be storage device, okay, in your batteries. So that's an opportunity. I want to just show you an interesting example, probably from the next slide here, okay. Here on the left, this is the what they call the hotspot temperature of transformer. That is what determines the life of a transformer. If we had only the grid as we know, no rooftop PV, no electric vehicle, we would only have that red line that you see is basically the standard that allows you not to go above hotspot temperature. You see on the left hand side which goes above, that normally we will have, okay, during the midday. But with the introduction of electric vehicle, we'll have another period of time where the life of transformer will be lost. And this is where many people in the developed world are now worried that electric vehicle will damage their transformer. But look, if you manage that electric vehicle with the photovoltaics, which is rooftop PV, you could actually eventually reduce the first peak and reduce the, and the second one remains the same because of electric vehicle if they're charged at night. But the first one comes down so much that you are going to balance it out. So there is an optimization that can happen for between photovoltaics, electric vehicle, and your normal grid. You could actually keep your transformer life to the same point. There are a lot of digital innovation that is coming into a smart grid. Some of the component that is very powerful is the phasor measurement units. And the phasor measurement units is basically something that measures all that is necessary in electricity node. You could use that to do a lot of good thing for you. For example, you could dynamically manage the power that flows through an electricity transmission system. When a transmission line is designed, it is designed for a particular wind speed and a particular temperature. However, the temperature could be higher or lower, and the wind speed could be higher and lower. So depending on the electric line sag, depending on the operating condition and the load that is flowing through the line, you could dynamically rate your transmission lines. So using the phasor measurement units, you could momentarily determine what is the real-time capability of that transmission line. That could actually, in return, save congestion problem in the transmission network. So you build a very large wind farm somewhere, and the wind is blowing. You can't bring all those wind power, which is renewable, into the grid because your line is congested. Using this technology, you could manage that congestion much better. So a lot of this is happening. The substations are changing. They're becoming digital, and they're becoming all dependent on what we know as IEC 61850 protocol for substations. And now substations are being monitored digitally. They've been interacted digitally, and it saves space in digital substation. A lot of those small wires that you have to do, connect all those relays and the units together, now can be only happening in one pair of fiber optics, all gone. So all this maze of wire will be just simply gone. You could have a smaller place for a digital substation, and the maintenance is so easier. Just those who work in substation, they know what it feels like with all those little cables. Okay, so to do that in our university, we actually put in IEC 61850 laboratory that emulates the digital substation and its protocol, and it also has 29 different IEDs from about 12 different manufacturers, so GE, Siemens, Cell, and all those, So we could study the interoperability of different companies as well. And that is very important for utilities, because you buy GE now, today, tomorrow you want to buy Siemens, you can't, because GE do not talk to Siemens. You don't want that situation. So we can demonstrate that interoperability in that laboratory. Electricity industry is actually changing. And I see myself a two-speed system emerging in the world. One is in the Western world and the one in the developing world. What I mean by that is, look at the electricity demand in Australia. See, it went like okay, in developing countries, and then it started going down. And that's because there's a huge investment into renewable. We expect that Australia will invest about $200 billion in rooftop PV alone by 2027. That's a huge amount of money. And you could actually take advantage of those $200 investment by private people by taking that money away from your investment. And you could actually save money and save electricity bill for consumers. So anyway, you see that, so the demand is, they are decreasing because it is being taken up elsewhere. Okay, that's the per capita energy consumption in Australia. It's decreasing. You go into Oman, this is Omani situation. In 2015, your energy consumption grew by 13%. And in 2015, your peak load increased by 7%, and you're chasing peak demand. And by putting in peaking units, I think you can manage it better, and you could become more efficient. There is opportunity there. When I was studying this in 2015, I saw that the electricity prices amazed me, because there are so much subsidies in electricity prices in Oman, and I don't know how long this could be sustained. It's a good thing if you can sustain it, but in reality it is not. And so in Australia, for example, now we are paying 46 cents per kilowatt hour in South Australia. And this is interesting, because this price is now one of the highest in the world, right? And that is why now there is a huge driver in Australia to bring the electricity pricing down. Okay. I just want to share with you some of the potential for smart grid implementation in Oman that came out of that smart grid roadmap study I just mentioned. The electricity prices in Oman are heavily subsidized. There need to be something done in that regard. The electricity authorities are chasing peak demand by putting new units. They are only used 10% of the year or less. There is still no serious attempt to encourage huge rooftop PV or centralized solar PV. Smart meters are used, but automated meter readings, but you could do so much. You could actually use AMI, full AMI infrastructure. And the concept of nanogrid, microgrid, these are not emerging. I think you should allow the private entrepreneurs to come in and build nanogrid and microgrids. An innovative technology solution for rural area power system is very important. I think that in rural areas, particularly where the generation cost is very high, modernization could play a big role there. And these are some of the other recommendations, and I'm not going to read all of them for you, but I think that one of the things in smart grid that I have noticed in Australia, that to manage a smart grid, you need a new generation of workforce, a new generation of engineers. And what you need to do is basically modernize your workforce. Surely they need the basic electrical power engineering or mechanical engineering degree, but then you need to train them on ICT, comms technology, and optimization, control, and those sort of stuff is very much required. In Australia, we have got something called Smart Grid Australia. It's an advocacy forum, and it actually educates people. It actually brings utility and universities together, researchers together, and I think that an advocacy, a Smart Grid Oman kind of group is probably is order of the day, which I think you could benefit from by educating people and to embark on a journey in Oman in the area of smart grid. So I will be available and pick up more on question and answer. 5 minutes I still have. That's amazing. I thought that I have gone over already. Anyway, so I think I will allow. That was my last slide, and the next slide was basically that some of the acknowledgements that are some of my students' work and other work that I have quoted from in in this talk. So I will stop here, and I think possibly I'll allow for questions. That's the best thing. Thank you very much for listening.
My name is Abdullah Al-Abri from Majan Electricity. Thank you, Professor Syed, for your informative presentation. I want you to just elaborate moving toward the future, moving from centralized energy supply to distribution generation. I'm not sure if this, what will happen in this side.
So it has already started to happen in many parts of the world. Of course, any change is seen with skepticism. However, we could learn, or you could learn from what other people are already experiencing and what things are happening in other parts of the world. I try to share some of it here. Centralized electricity generation is necessary when you have got an electricity system where the energy flows from the generators to the consumers. But when the consumer becomes also producers, when commercial entities become producers, when wind farms become private investment, when large-scale solar become private investment, then I think the grid has to think very carefully how you are going to manage all those distributed generation. So yes, you have got challenges. For example, a simple challenge is when you have power flowing in one way, protection system is so easy to design because you are basically designing protection for radial power flow. But when power also is flowing from here and there's a two-way interchange, all the protection settings gets upset, right? But it can be managed. I think with clever management, with smarter technology, with more communication between different points in the network, I think we could manage it, and I think that's the future. There's no way out of it.
Okay. Other questions?
Thank you, Dr. Syed, for this presentation. There was always an issue about the penetration level of the DG or distributed generator in the distribution system. So is there any certain limits that, okay, we can encourage, but then again, we have to be conscious when we reach to a certain level. Otherwise, then this might create some instability in the distribution network itself.
Absolutely, that's a very good question. I think this, in the utilities where a lot of distributed generation are now being penetrating, this question is actually in the dream of utility engineers when they are sleeping, because they are scared that what is going to happen if this just continues to grow indefinitely. The answer, that the way that I look at it, so for example, many utilities now saying that we could have 80% renewable energy penetration by 2025, 2030. It is not impossible to have that if you can manage it well. So, for example, if 80% you have got, let's say, wind and solar, and suddenly a cloud comes in, okay, or the wind stops to blow, how are you going to manage your load, your frequency, your voltage? Now, if you have got backup generation, if you have got a storage system, okay, if you've got interconnected power system that you can draw in power from other parts of the network, or you have got microgrids where you have got dispatchable microgrids, which in case that the utility is in emergency, you could actually then borrow power from the microgrids. And nowadays, this dispatchable microgrid, nanogrid concept is emerging. So that means that utility signs a contract with them, says that, okay, we will be there for your reliability, but you will be also for our reliability. So I could also get power from you when I need it. So penetration level is an interesting thing. A lot of different studies have been done. Rooftop PV study that the solar city that I just showed you, one objective for me is that if 100% of the houses in that distribution transformer gets, 100% of the loads in that distribution transformer have rooftop PV, what will happen? And the solution, the answer was not much will happen. Actually, voltage could be managed, the distribution transformer life will be increased, and you could have a lot of penetration. But it needs to be managed very carefully.
Thank you.
Thank you very much, Doctor. I'm not a technical guy. I will ask a layman question. Yes, complicated network now, you have explained. But what impact this could bring to the customer? All the impacts here I could hear from our perspective, from network perspective, how to manage the load, how to manage the currents in the network, but we could not see from the customer. Is it impacting the customer? Any risk to the customer having the batteries in the house or nearby into the in their area, in their resident areas? What risk can bring to the customer, and how, based on your study, you could prevent any risk to the customer?
So if I understand your questions properly, I think you probably referring to two kinds of risk. One is probably the risk of losing power, or risk of basically electric system reliability. And the other risk, are you referring to also risk of human life, safety?
Yes, the hazard to the customer.
Okay. Okay, so I'm not an expert in safety hazards and that's part of things, so I will be commenting very generally. I think there are other people among the speakers who probably will answer that better, but and I invite you to do so if you know in your talks, cover this place. But what it is that I have not come across an incident in Australia that we had rooftop PV and inverter and battery storage system in our garage and that we had got problems. Islanding is an issue. So for example, if you have got rooftop PV and your electricity grid is disconnected, people may go and work thinking that, well, the electricity network is isolated, so islanding becomes an issue. So as long as you have islanding protection, as long as you know that you have got rooftop PV and your DC side is energized, I think maintenance issues then could be, safety issues could be avoided. I have seen wind turbine generators catching fire. Okay, that is on the roof, on the tower, and it has caught fire. Okay, but is that a risk to human being? Possibly not. We lost the wind turbine, but it was not risk to the people there. So I don't know. I mean, I think that I haven't come across a situation where it has been demonstrated that it is a very much risk. In terms of renewable, there are people who complains that the audio noise level from the wind farms are quite high, and that's damaging their ability to hear well. Well, I think this is why wind farms are now all onshore or either offshore. So I think you could manage it that way. So safety to human being is a concern. You could manage it.
And we are putting one recommendation, especially for researchers or lecturers, since you have your student, to embed the from customer perspective safety in the researches. Whatever we are doing now, for example, distribution companies, we are converted to a customer centric. We want also the research from other side to focus in this area, to think on how it will impact the customer, how customer will receive it, how it will impact the customer. Thank you.
Thank you, Mohammed. Last question from Engineer Ali.
Thank you, Doctor. Thank you, Professor Islam. My question, I think, is to Dr. Amr. It's regarding as a capacity of what they call the previous job of chairman of a regulator. Knowing now what they call the oil price is going down, and the natural gas is what they call is going up, and our generation, it depends on what they call the natural gas, and we know natural gas is already subsidized. Plus the distribution electricity is subsidized. So how we could balance what they call to motivate and encourage the investors to go through renewable while still our what they call the energy or our power or our electricity is kind of what they call cheap compared with the renewable.
Thank you, Ali. First of all, just to correct you, I'm no longer the chairman for the authority. So my term expired last May. But just like a quick response to your question, yes, maybe the oil price is going down. That's true. But in the other side also, we need to keep in mind fossil fuels will no longer continue to be sustained. So today or in the future or in the coming future, we expect the oil and gas will vanish, and then there will be the challenge. And if we didn't put any effort right now, where we have the I would say the capability to build in renewables, then we'll not be able to do it later on. So that's we should put incentive. We should go further with the to go for renewables. In the other side, also we see renewables technology itself evolving. The price is not as it used to be a long time back. Technology also helps a lot renewables to become more reliable, more, as Professor Syed Islam said, just like in his slides, storage improved a lot, and then control of renewables to become sort of reliable source becomes more available and more efficient. So I think the trend is in that direction right now. Okay. So thank you, Professor Syed.
Thank you.
نماء لرخاء يدوم.